Qantas Flight 32. On the 4th of November 2010, Qantas Flight 32, an A380-800 passenger flight, was flying from London to Sydney with a stopover at Singapore Changi Airport. The flight had a total passenger count of 440 and 29 crew members. The pilots of the flight were Captain Richard de Crespigny, First Officer Matt Hicks, and Second Officer Mark Johnson. 4 minutes into the flight from Singapore Changi Airport, Qantas Flight 32 suffered an uncontained engine failure due to defective engine manufacture. The failure occurred over Batam Island, Indonesia, and the aircraft had to make an emergency landing back at Singapore Changi Airport. This failure was the first of its kind on the Airbus A380. Upon inspection, it was found that the turbine discs in the aircraft's number 2 engine had disintegrated. The aircraft suffered damage to the nacelle, wing, fuel system, landing gear, and flight controls for engine number 1. The failure was deemed to have been caused by the breaking of the stub oil pipe in engine number 2. Fortunately, there were no injuries to the passengers, crew, or people on the ground. However, some debris fell onto Batam Island. This incident occurred at 10:01 AM Singapore Standard Time. The debris that fell included a large piece of the nacelle. This debris caused damage to houses, the school, and the car.
Sequence of events. After about 2 hours of refueling time in Singapore Changi Airport, the Qantas 32 was ready for takeoff. At 9:57 AM local time, Qantas 32 lifted off right on schedule. After takeoff, the autopilot function is turned on. The ECAM is clear. It is also known as Electronic Centralized Aircraft Monitor, which keeps watch over the myriad of onboard system and alerts the crew on the slightest malfunction. It's 10:01 AM. The pilots are just 4 minutes into the flight, and suddenly, everyone on board the plane heard an explosion near the wing. The pilots realized that they were losing an engine. Boom! The pilots evaluated the situation, and the captain, with 35 years of experience, immediately took over from the autopilot. The ECAM warnings just keep coming. The number 2 engine is overheating, and this damaged engine is dangerously hot. The plane is now in a state where it can become a dangerous fireball. This is because the wings of an A380 aircraft are filled with tons of highly flammable jet fuel. Let's get into the details of why the fire occurred in the first place.
Crack in the oil feed pipe was a result of fatigue and had developed over some time. It had grown to a size that allowed oil in the pipe to be released into the buffer space between the bearing chamber and the hot air surrounding intermediate pressure turbine disc. The oil was released as an atomized spray, which was then ignited due to the hot air in the buffer space. The fire propagated through the bearing buffer space and eventually to the intermediate pressure turbine disc system. This caused the disc to separate from the drive shaft. The disc accelerated to a speed in excess of its structural capacity and burst into 3 main segments, with enough force to puncture the engine case at high velocity. This accident was due to the misalignment of the oil feed stub pipes, which occurred because the pipe itself did not conform to the design specifications.
Impact on the flight due to the incident. Due to the uncontained explosion, the aircraft had to turn back to Singapore Changi Airport to do an emergency landing. In order to assess the situation, the captain flew in a holding pattern for close to 50 minutes. After the initial assessment, the first officer and the supervising check captain then input the plane's status to the Landing Distance Performance Application, or LDPA for short, for landing 50 tons over maximum landing weight at Changi Airport. Due to the aircraft being overweight,
the pilot has to land the plane at a much higher speed. This is because The plane will lose lift and drop like a stone if the speed drops any lower. Too fast and the plane won't stop before reaching the end of the runway. This is a precarious balancing act. The plane is gobbling up 80 meters of runway every second after touchdown. Half the spoilers not working, we had the ailerons not making speed brake caption. If they don't slow down quickly, they risk overshooting the runway and crashing into something. To prevent this from happening, the pilots had to go on full brakes. Finally, after 2 hours of audio, Qantas 32
landed 35 knots faster than normal, which blew 4 tires. Upon landing, the crew was unable to shut down the number 1 engine, which had to be doused by emergency crews for 3 hours after landing until flameout was achieved. No injuries were reported among the 440 passengers and the 29 crew.
Wow, that was hot. Good job. Good job, everybody. Good job. Thanks. However,
The A380-800 aircraft had to be sent for repair, and it was the most expensive and most extensive repair ever done to any aircraft. At an estimated cost of 139 million Australian dollars, 4 new engines were mounted. The whole left wing was repaired, with 6 kilometers of new wiring. The repairs added 94 kilograms to the weight of the aircraft.
actions taken after the incident.
Regulatory authorities and operators of A380 aircraft with Trent 900 engines took a range of steps to ensure that high pressure and intermediate pressure hub assemblies with non-conforming oil feedstock pipes were identified and either removed from service or managed to ensure their safe continued operation. Rolls-Royce also released an engine control software update that included an intermediate pressure turbine overspeed protection system, or IPTOS for short, that is designed to shut the engine down before the turbine disk can overspeed, in the unlikely event that a similar failure occurs. Rolls-Royce has also made a range of changes to their quality management system to improve the way in which they manage non-conforming parts, both during the manufacturing process and when it has been identified that parts had unknowingly been released into service with non-conformances. In addition, our group has come up with solutions that can be implemented as well, one of which includes a maintenance checklist to include more stringent inspections on alignments on tubes and pipes within the engine, since this accident occurred due to a misaligned counterbore within the stop oil pipe, which led to a fatigue fracture. Secondly, the installation procedures should also include a final quality check on pipes and tubes being installed. In the case of this accident, the pipes were not checked thoroughly for quality itself and were thus sent out for assembly, ultimately causing the accident.
Thank you for your kind attention, and we have come to the end of the video.